Example number 2 of lesson 2, we're looking at finding trigonometric ratios. So we have cosine of A equals 9 over 13. So what that means is cosine of some angle A of a triangle, a right triangle. So draw a right triangle and label some angle A. I'll let this angle equal some angle A. That is 9 over 13, meaning its opposite or adjacent side over hypotenuse, which means that 9 is the adjacent side and 13 is the hypotenuse. So label the hypotenuse first. It's always across from the 90. So our hypotenuse is 13. And then always label a opposite. Opposite side would be there. And then adjacent side is the last remaining one, which this is equal to 9. Now I want to find the exact values of the 5 remaining. So I want to find secant of A. That's just flipping the fraction, right? And then I want to find sine of A, cosecant of A, tangent of A, and cotangent of A. All right, so sine of A is opposite over hypotenuse. Well, I have the hypotenuse, that is 13, right? I just don't have the opposite side. Cosecant, it would be flipped, and that would be 13 over our hypotenuse, which I don't know yet. Tangent is opposite over adjacent, right? Opposite over adjacent, which I have the adjacent side, right, which is 9. So I just need this opposite side. Well, on a right triangle, how do I find the third side if I'm given 2? Well, that would be the Pythagorean theorem, right? So if I want to find opposite side, that is similar to a squared plus b squared equals c squared, right? Opposite side squared plus adjacent side squared equals hypotenuse side squared, right? So if I want to find opposite, then I just need to get it by itself, right? So I need to find my opposite side. I'm going to take the square root of my hypotenuse squared minus my adjacent squared. Okay, and then you can come up with similar formulas, just switch those for adjacent. Now you got to square them first and then subtract them and then take the square root. So the last thing you do is take the square root. And then if we want to find hypotenuse, hypotenuse is opposite squared plus adjacent squared, and then you add them together and then square root. Okay, so here we're dealing with 13 squared is 169, and then 9 squared is 81. So if I take 169 and subtract 81, I get 88, and then I'm going to square root that. So opposite is the square root of 88, which breaks down, and I can put into 4 into both of those, right? So 4 goes in both those. I'm left with 22. 22 doesn't reduce, so I get 2 square root 22. All right, so 2 square root 22. Sometimes it's better to leave it as a square root like this, square root 88, before you reduce it. So for whenever it's on top, I want to leave it in a reduced form. So our opposite is 2 root 22, so I can leave it there. But when I flip it on bottom, I might want to leave it as square root 88, because then I just want to multiply top and bottom by 88, or square root 88. And square root 88. So then I can rationalize it, and we get 13 root 88 over 88. And then you can keep on going from there if you want to, or you could leave it as the 2 root 22. That would be fine as well. So this one would be 2 root 22. The bottom would be flipping this, so that'd be 9 over 2 root 22. So I could do that and then multiply top and bottom by 22. Root 22. And so you get 9 root 22 over 22 times 2, which is 44. So that's the reduced form. So this one I could reduce it because I can take out a 2 again. I can turn this right here into 2 root 22, and that would be 26. So I'd get 26 root 22 over 88, and then I can divide those by 2, and I get 13 over 44. So this one is 13 root 22 all over 44, and I can't divide that one anymore. Okay, and this one is reduced because 9 and 44, I can't reduce those two. 2 and 9 can't reduce those two. 2 and 13 can't reduce those two. So those are all 6 of them. So hopefully you kind of understood that. So the basic idea is just make sure that you label your right triangle, label your hypotenuse first, and then based on the angle that you're given, so just doesn't matter if I put the A here or the A here, because if I put the A down here, right, this side would be opposite and this side would be adjacent. But you'd still get the same 6 trig functions. So hopefully that helped you on that one. If you need another example, here is another example for you. Let's see. So if I have another one, we can do, let's see, cosine or sine. You can try it on your own. Sine of b equals, here's an easier one, 4 over 5. Okay, so you draw a triangle, label your hypotenuse, and then pick, you want that to be b or you want that to be b. It really doesn't matter. And then go ahead and find out those 6 trig functions.